The answer should be 146. Answer is 2. Answer is 185. Answer is 24. Answer should be 0. Pick a number from 1 to 5. The winning number is 6.
That's cheating.
Why?
Because you said 1 through 5.
Oh, do I have to pick 1 through 5?
Yes.
3.
That was yesterday.
To perform matrix calculations on the TI-83 Plus, after today, I can use the cumulative sum, fill, identity, augment, row echelon form, reduced row echelon form, row swap, and row add functions in the matrix math menu on the TI-83. Example number 1. The cumulative sum, it returns a matrix of the cumulative sums of matrix elements. So in other words, it'll look like this. 1 and 2, 3 and 5, for example. And the cumulative sum of each column would go like this. What's the sum of column 1, cell 1, just by itself? 1. So now below that, what's the sum of this cell plus the one above it? So there would be a 3 here in the new matrix. This one would remain 3, but the one below it would be what? 8. So it will do that for you. Here's a matrix that I already had in my calculator. It's matrix A. And I would go to the math menu and choose 0 for cumulative sum. And then after that, I would have to enter in the name of it, which would be matrix A. You can try this on any matrix you have in your calculator. Type in the name of matrix A, and then come back with the cumulative sum matrix and take note of what has happened here. We can test it out. You have a 3 to start with, so there should be 3 here, and that works. And then 3 plus 2 is 5, so that's where it's at. And then this one is the sum of itself and everything above it. So 3 plus 2 plus 5 is 10. And it works out for every column in there. Here's a practice problem for you to do, and you walk by with it and show me the calculator screen. None of this FBI badge flashing. You actually have to hold it out long enough so I can see it, and then I'll say yes, and you go by. Type that one in and find the cumulative sum matrix for this. I noticed some of them were wrong down in here. We won't do the whole matrix, but 1 plus 7 is 8, plus 11 is 19. There were some that had 9 in there, which means you've probably only put a 1 in this cell instead of 11, so you have to pay attention to what you're typing in. Now I have bonus problems made up just in case we have extra time. If we do, I'll go back and give them to you at the end. But to be certain we get through everything, I'm going to go straight to the next one. Example 2. The fill command stores a value to each element in the matrix name. In some cases, when you're using this, you may have to have the same number in every cell in the entire matrix. So instead of going through and typing them all in one at a time, especially if you have a 7 by 7 matrix, you can give it a command and it'll fill it in for you. So let's say we have matrix B. And this may be a mistake from PhotoStream. I'm assuming that it's in the right order, but I don't know why matrix B would be up here, but we'll look at the next one. Oh, well, okay, we can do that. There's matrix B, and it already had something in it. So the command is fill, and then the item you want to put in there, which in this case I want to put all 5s in this matrix in B, and then the name of the matrix I'm putting it in, which is B. Once you do that, you hit enter and you'll get the word done. and then it'll show you the matrix if you type in this first. You have to type in the name B. So go back to your matrix menu and stay in the name column. Choose B, hit enter, and then it'll show you the matrix that has all 5s in it. Simple enough. Now try this practice problem and I'll tell you what you're going to fill in. Fill in matrix F with 4s, and matrix F should be a 3 by 3 matrix. Bonus problem for 2 million. Answer to this one should be 169. Yes. Example number 3. The identity function. And when you're dealing with matrices, you have something that's called the identity matrix. And an identity matrix looks like this. First of all, it's going to be square. So it's going to be 2 by 2, 3 by 3, 4 by 4, and so on. Let's say it's 3 by 3. The identity matrix is going to have 1s in a diagonal from top left to bottom right. Everything else in there will be 0s. Now instead of, if you need an identity matrix, instead of going in and having to type 1, 0, 0, 0, 1, 0, 0, 0, 1, all you do is use the identity function. So go to second matrix math, hit number 5, it'll take you to the function, and there it is. Shows up on the screen. And let's say we want a 4 by 4 identity matrix. So simply type in 4, hit enter, and there it is. There will come times later on where you need an identity matrix and you can save time by doing this. If you don't, you're going to take longer than everybody else. So if you don't take advantage of these shortcuts, you may take 3 periods to take a test. Somebody else might be done in 30 minutes before the end of the period. So make sure you know these. Here is a practice problem. Create an identity matrix that is 5 by 5. The 5 by 5 matrix should have 1s like this in a diagonal, and everything else should be 0s. We have time for a bonus. Answer to this one should be 40. Example number 4. The augment function. Augment means you're going to add something to it. Not literally in terms of addition, but adding as if I have something sitting here and I set something beside it. I've added something to it. So that's second matrix math and the number 7 for the speed dial. But what it does is if you type in this first matrix name and then the second matrix name, this second matrix will be inserted into the first matrix off to the right as new columns in the matrix. Of course, it helps if they're the same dimension as well. So we'll start with this matrix. I have A. I have 3, 2, 2, and negative 3 in matrix A. And then in matrix B, I just put all 5s in there. I had that left over from my identity function. Or not the identity, but the fill function. So now I want to augment this. I want to put this to the right of matrix A and create one matrix. So to do that, I use the augment function and type in matrix A, comma, matrix B, and hit enter. And you should come back with the result here. Notice it puts the values to the right as new columns in matrix A. So you have just one new matrix now. Here's a practice problem. You should augment matrix C with matrix D, and there are the values for each. Your new matrix should look like this: 1, negative 2, negative 2, 9, 3, 6, 6, and 2. We have time for another bonus. Answer on this one should be 10. Example number 5. the ref. This is not a ref function as in it's going to officiate anything. It's called the Row Echelon Form. That's why it's REF. And Row Echelon Form, if you'll remember back to solving 3x3 systems of equations, I'm not going to write the actual numbers here. I'm just going to put dots in their place just to make the point. Let's say you have x, y, z, and then a constant. And you have three equations. Your goal when you solve by elimination is to eliminate this position, and this position so that you have a variable equal to a number, and then you can solve backwards through that. And instead of doing all these calculations yourself, the calculator will do it for you. It'll do all the solving and go backwards. And this is the point where people say, well, why didn't they show us that before so I didn't have to do all that work? Well, it's like when you become president. You learn what happened years ago. So there's a secret folder and things like that. But now, this is a echelon form here, like that, a wedge shape. It will create that for you. But first, you have to have an actual system of equations that will work out. So I have one for you. And this represents a system of equations right off the bat. It is a 3x4. So you have 3 rows and 4 columns. You can only see 3 columns at a time on this. This is what it looks like altogether. So you go to the Math menu in the matrix frame and choose A, the ref function. There it is, and mine is in D. So I'm going to type matrix D, and then it's going to come back with the row echelon form, which you cannot see all of this right now. But what you can see on the screen is you have a 0 here and a 0 there, which means when you right arrow over to the right, you'll be able to see what's in there. And what's coming up next is not required, but what I did is I went back and did the ref function and stored it in E to see if it would make it any easier to view. And when I did that, it doesn't make it any easier to view. So you can right arrow over to, and there it is again. And now over on the right, here's where we need to be. This represents the 4th column and the 3rd column here. This is the 3rd column, this is the 4th column. So right here there's a 1. That means that's 1z. Z equals what? 2. 2's out on the right. If you have a 1 in place here where the z position is, that means z equals this number, which is 2. So then you would go back and plug it into the equation above it, which, if you'll remember, had a 0 out at the beginning, and then there's a number next to the y and a number next to the z. You solve backwards for z, and so on. Alright, here is a practice problem. Enter this in matrix F and find the row echelon form. You don't have to right arrow when you bring it up here. You can just show me the first 3 columns. Remember, you're typing in 3, 2, and what's this? -1, -2, -1, 5, 4, 5, -3, and don't forget your 4, 11, and 5 out there. Example 6 is the reduced row echelon form, which will hand you the answers outright. So for example, I go to the Math menu and choose B for Reduced Row Echelon Form, RREF. And I'm going to use this on the matrix that we just did in the last example, which I think we put in matrix D. And when I do that, look what comes back. You have a 1 here. Now what variable position is that? That's X. And that means X is going to be equal to what? 4. What is Y equal to? 10. And Z is equal to what? There it is. Solves it out for you and you're finished. For this practice problem, you solve this one that I'm going to put up here, and you don't have to bring your calculator. You only have to bring the 3 answers that apply. So write X, and don't even write that. Write them in alphabetical order. Write number, comma, number, comma, number. And no variables listed at all. From F, from matrix F, we had a matrix F. Find the reduced row echelon form. Matrix F should still be in your calculator. The answers you should have received were 1, 2, and 3. No time for a bonus problem. Example number 7. The row swap, and it does exactly what it says. It's going to swap rows within a matrix. First, you have to identify the matrix you want this to happen in, and then identify the two rows. And you're not going to type the letter A or B. That's only an algebraic way of referencing the rows. You're going to type in the row number. For example, row 1 swapping with row 2. So in matrix D, I'm just going to leave matrix D in here. And here's what I'm going to do. Go to Math and then choose C. That's row swap. And do row swap for D, comma, 1 and 2. Rows 1 and 2 are going to swap. And if you'll notice, there's the final result already. These two rows have switched positions. So if you ever want to make a program that solves for a 3x3 system of equations or whatever, you can give the command to swap rows in here based on certain conditions. Here's a practice. Use matrix A as it is up here on the screen and swap row 1 and row 2, and your swap command must be present above the final matrix. You can't go in and just type it in. You have to do the swap command. Your final answer should be 4, 9, 7, 2, and then 1, 2, 3, 6. Example number 8. The row plus function. It'll return a matrix with row A of the matrix added to row B of the matrix, and the final answer is stored in row B. You're adding row A, row B, whatever's in row B is replaced with that sum. So I'm still going to use D. I just left D in here. And I'm going to do the row plus function and type in matrix D, comma. We're going to add rows 1 and 2, and the result is going to be put in row 2. So if I add these together here, I should have an 11, a -3, 2, and 18. And this result should be put in to the second row and replace what is there now. And there it is. 11, -3, 2, and 18. Again, that's the result of adding these two rows together, and whatever that sum is replaces row 2, goes into that spot.